this is a really interesting thing to see some of these different crops. So I'm going to talk specifically about a case study that we've been working on over the last 5 or 6 years related to a prototype for variable rate drip irrigation. So we all know that if you look at an image, that in some cases you can see there various levels of homogeneity or not. And so, but we know that vineyards are variable. If we look at a yield map, by the way, this is another project that we've worked on for the several years, being able to map grapevine yield at the field scale using high resolution GPS and load cell technology on the discharge belts. We can get an accurate estimate of actual weights in the field at harvest. And so this is really the baseline layer that we use to say whether or not we're doing something correctly, incorrectly. It just gives you an end of the season gauge of how you did. So we have in some of these vineyards, this is a Petit Syrah block in the Lodi-Galt region. This vineyard, you can see running right through the middle, you've got high, low, and medium yielding zones all in the same row, even though all of this is managed uniformly. 5 times the difference is pretty normal. We've seen 10-ton differences in some cases as well. And when you're talking about San Joaquin Valley growing, any increases that we can get in some of these situations is beneficial. We see the same thing from the imagery that matches our yield maps fairly well. In some cases, in others, because we do quite a bit of manual hand manipulation to the vines when you start dropping crop or pulling leaves or something like that. Sometimes the NDVI or imagery relationships can break down in some cases. So the yield map is the final. And then we look at most of it as a response to the plant available water and soil texture. So the big things that we're trying to do with this system, with precision viticulture in general, is to manage, to optimize performance. So we want to get the best that we can. We have the additional constraint in wine grapes that we also have the quality component that we have to look at. So these are pretty big steps to be taken. And then it just goes hand in hand with minimalizing that environmental footprint. So the irrigation, we think, is the biggest tool it's the biggest hammer in some cases that we have in order to minimize some of these vineyard variability issues. So variable rate irrigation has been, I'm sure most of you guys have seen the work that's been done in other systems and center pivots and in the Midwest and other crops. In wine grapes, for the most part, this has been, the irrigation practices have generally gone towards a management zone where we're looking to have wine quality A goes for one price and wine quality B goes for another price per bottle. And these management zonal systems aren't very flexible. So, for instance, if you've got a field where you have soil type 1 and soil type 2, you've got from an EC map or from imagery, whatever the source is, and you pipe it to where you're irrigating 2 management zones, essentially. Well, if you have a case where you have some other, not necessarily soil type, but something you missed, or you've got a different disease pressure or whatever it is, but another source of variability in the field, you don't have any kind of flexibility to manage that. So what we've thought about is sort of a modular irrigation system. And so what we're looking at is trying to very much target specific zones and very small areas where we can manage the whole field no matter what we have any kind of differences. So we pixelize that into what we've sort of started referring to as pixel farming. And then if we want to, we can go into wine program A, wine program B, something like that. So the objective here, and the beginning of this talk, and I think some of you guys have probably seen some of this as well. We started this in 2012 with IBM. Most of the components are from NetFM. A prototype, proof of concept program to increase yield in low vigor and improve water use efficiency overall. So there are two ways to sort of think about this vineyard variability issue. There's the management zone kind of a section, or even just manage your different areas differently, or there's try to reduce it, try to remove it. And for us, if we're talking about a 600,000 gallon tank at our Livingston winery, the more homogeneous we can make that fruit, the better for our overall wine quality. So as I said, we're not too far away here. This system was at Colony Ranch, just north of Lodi, south of Sacramento. Nice, pretty picture. And this is one of the yield maps, the yield map from this year. This is 2012 yield. And you can see that there are areas of significant variability in terms of yield. It's a 30-acre field. We put a 10-acre block, put 140 15 by 50 meter management zones inside. So we essentially have 140 irrigation sets in 10 acres. We outlined a conventional site at the bottom of the field just as a way to give us a gauge on how things looked from an area that's irrigated with the conventional system. And we picked this area specifically in some ways because of if you look at the variable rate system on the top, you have a really low yielding section in the northeast or the northwest, and a really high yielding section in the southeast. And we have similar patterns of variability in the southern part. So these zones were lined up specifically with the Landsat satellites. Landsat 7 actually in this case, but Landsat 8 just through some reinterpolation is essentially the same grid. These are 30 meter. We would refine those down into 15 by 15 meter zones to where we're irrigating based on satellite response. This is the layout. So as you can see, there's a lot of infrastructure that goes into a system like this. I want to reiterate the point. This is a proof of concept, not necessarily something that you would want to put in the field necessarily. I'll get to that shortly. And the way that this works is we had a blind hose at the top with solenoid valves and check valves that will let water pass through certain zones or not. It's the engineering side of the system. And the blind hose on the top is probably still one of the only things that we've kept over in some of the new systems. Like I said, this was developed with IBM, so you can imagine there's one of these things every 15 meters in every row for a 10-acre piece. This is not a cheap system. And it also, throughout the 2012 to 2015 seasons, we had 2 IBM engineers that were on full-time call to be helping us run the system. So the dollar amount starts to climb fairly high, but again, proof of concept. Just some of the other pieces and the control and the power station. So all of these can be toggled on and off at this base station. And this system can be used to irrigate according to vine size. So you give your small vines small water, your big vines big water, something like that. Or you can apply more water to low vigor areas, try to build up the capacity, and try to increase the yield and decrease the variability. We think if we can, without planting another acre, if we can drive up maybe the bottom 30% of the histogram into at least field average, these kinds of systems will pay for themselves in the long run. So we would like to go for number 2, but if we have to, number 1 is a viable option. We are one of the lucky ones in grapes where we practice deficit irrigation pretty much all the time, regardless of drought situation or not. How you get to what number you apply in terms of a management factor is a different story. So this is a broad outline of the way that we ran the system over the season. We would drop it, and you see in May, that 4 weeks, that 0 to 1, the high yielding areas, the big vine areas, would get no water. And some of the lower vigor areas would get 100% of ET or some difference between there. In June, when we want to start introducing the deficit And then July through October, some of them more stressed than others, some not stressed at all. This is a change in NDVI as we go from the early season into the mid-season. This is as percent maximum, so it's a fairly small scale that we're talking about. And you can see the patterns, the overall patterns in vine vigor are reduced as we go through the season. So this is just, these are the yield maps specifically set out to the conventional and the VRDI section. We had to manipulate the grid a little bit here because we've got power lines on the south end of the field. And you can see here the main point is that while the pattern changes somewhat, it doesn't change drastically. You have sort of a pattern as you go from the northwest to the southeast of low yield, and it changes seasonally, but the pattern's generally the same. Versus when you compare with the variable rate system on the top, what you see is in 2012, this is before any installation happened. This is the yield map that we got before the system was put in place. 2013, where we were trying to reduce variability, and 2014, we probably were giving a little much water to the top and not quite enough. We're still working on how we refine some of the scheduling aspects of this, but we were able to flip. This is one of the big powerful things about this kind of a system is we were able to flip the pattern of yield in just 2 years. And then in 2015, we went back towards the idea and the goal of reducing vineyard variability. Yield changes as season changes. This is a Cabernet field. If you guys, anybody in grapes will remember in the Lodi area, we had a pretty significant cooling period right around bloom in 2015. So we had a pretty significant yield decrease, but we were able to maintain more yield than what the conventional system. Some water use efficiency numbers. So in 2013, 14, and 15, water use efficiency is up every year, and yield is up every year. So we have an increase in yield from 4 to 16%, with 10% the average. And in water use efficiency, we have an average of 12% increase in water use efficiency. In conclusion, the modular rate system was successfully implemented, although with some pretty major heartaches over some points. My interns really enjoyed walking up and down those rows every day. Vine growth was effectively and more quickly than we expected manipulating, and yield was increased during 3 seasons by an average of 10% and up to 17% gain in water use efficiency. This prototype's expensive and complex, but an excellent template for the second generation system. Second generation system was first installed in Israel in 2015. This system takes all of the control out of the field and puts it into control boxes at the ends of the field. So this system will operate from a master controller at some place in the field, and then it controls each of these boxes depending on how many pixels that you have. And this also decreases the amount of labor that we have to use to install a system. For the most part, this one rolls out very similar to what you would see in a conventional system. This system we then installed in a 25-acre Malbec field in the Livingston area. And the thought here is you put the box in, and each one of these valves will control green. Yeah, there we go. So each one of these color-coded valves lines up with one of the colors. You can't see them here, but these lines are also color-coded. So each of these valves irrigates a 30-meter pixel. So we went away from the 15-meter pixel into a 30-meter pixeler zone. And so each one of these valves will control one zone. It's 20 vines wide and 9 vines tall. We have the master controller at one end. I have a mirrored image of whatever's on that controller on my cell phone or iPad. This can be controlled from anywhere. You click on one of these, the schedule's all uploaded at once, but if you click on any one of these zones, you can manipulate the schedule from anywhere in the world. Click on one of the boxes, so this number 1 box would control irrigation zones 1 through 16, 17 through 32, and so on. click on one of these boxes, and you get there's a flow meter on each one of these boxes, and you get a real-time flow rate as you're irrigating. So we have 96 30-meter zones in this 25-acre section. 2017 installations, we're going full speed ahead with about 200 acres over this season and next season. These are full blocks, not trial. The previous one, there's another 50 acres this way. These are full blocks. We've got, this is going to be the most challenging one. There are 300 or 400 zones in this block. This is the first that we've done that's a new planting. So we think that this will reduce costs significantly when you're putting this into the field initially as opposed to a retrofit. And then another retrofit in Sonoma. This is in the Madera area. This is Livingston, Modesto area, Sonoma, and the Madera, southern Madera County. The next steps, we're working to streamline the energy balance model for better use in vineyards, and then to automate the calculation of management factors, which we've seen to be one of the things that's a major driver. If you change from a 70% to 80%, it's a pretty significant increase in water, and so those things we need to refine a little bit better. And the economics of these irrigation zone sizes. We went from 15 to 30 meters. 30 meters is appropriate, or some. We think it's appropriate for the imagery that we have. We've got the European Space Agency has the Sentinel satellites that are going up that are higher resolution than Landsat. We think we'll be able to have good imagery for use in this kind of a system for a long time. Landsat certainly sufficient to this point. And then we want to this point, we have not gone into nutrient or fertilization management, but that is a goal this season and the next few seasons. We've wanted to just look at the effects of changes in water, and now we're going to be looking more also at fertigation and nutrigation. I think I haven't seen that before. Interesting. So just some acknowledgments, everybody in our lab and my teams of interns over the years. The TJ Watson lab at IBM, and the guys in San Jose as well. Netafim, Avi Itamar have done a fantastic job at helping us sort of install this stuff, and Todd Rinkenberger as well, and then some others that have helped us along the way. So, thank you. Time or no? Go after? Time for questions or?
I think we'll save the questions till the end for everybody. We just have one more presentation. Meow. All right. Gene Meow from UC Davis is the UC Cooperative Extension Farm Advisor. He focuses on vegetable crops and the impacts of drip and tomato for growers, for growers, including economics and productivity. The vegetable crops program that Gene oversees fosters appropriate research and collects and disseminates relevant information to growers, processors, and related industries in the California vegetable industry. Gene's areas of research include local variety adaptation, trial evaluations, local disease management strategies and practices. Most of the research is conducted in commercial fields in cooperation with growers and is often collaborative with UC specialists. Thanks, Gene.
Thank you. So I'm a local extension advisor in the Woodland office, covering a couple counties. This is a presentation on processing tomatoes. The file really is from Tim Hartz, and Tim's in the back there. So I'm pretty much giving Tim's presentation. So if Tim has some comments, he can certainly chime in. So I think the story for canning tomatoes is a good one. That yields have gone up over the years, water use really hasn't. So water use efficiency is sort of the driver. It's been more tomatoes per drop of water. So if we look at the California tomato industry, it's really grown over the years. It was about a 2 million ton industry, or 3 million tons back in the 60s. It's been just sort of a now up to about 14 million tons. It's dropped back a bit to be about a 12 million ton annual production because of oversupply worldwide. And so there's I think maybe it's stable around 12 to 13 million tons or so. And in California, we're producing something 90% or 95% of the U.S. production and about a third or so of the world production. And nearly all of it has pulled back into the Central Valley, as into the, I guess in the 70s and 80s, there was, and earlier, there was some production in the Imperial Valley in the very southern end of California, for the early production, and then a lot of coastal production areas, including sort of our central coast. But that, while there's a little bit of production remaining there, is really very much Central Valley oriented, and the biggest producing areas down in the Fresno, Kern County, in the west side of Fresno. Okay, if we looked at the industry kind of traditionally, it had historically been furrow irrigated oriented. Sprinklers to start with, in some cases, sprinkle irrigated season long. Sprinklers oftentimes, especially on the west side, pre-irrigated with these hand line move systems. It has certainly developed into using much more drip irrigation and has become subsurface drip irrigated with the strip tape. Why this sort of movement into drip irrigation? Say, for myself, I thought in the Sacramento Valley, I started in the 1980s, and I thought for our Sacramento Valley, where we had plenty of water, we thought, and it was relatively cheap, that I thought that I would make it through my extension career without seeing very much, I mean, a limited amount, but not very much drip irrigation being used in the north. Very wrong. And clearly what happened in those early days, there were some innovative growers in our area, and they were looking at drip irrigation, the tape with some of the Netafim stuff that was hard-walled plastic, and a lot of the connections, though, with the delivering of water. I looked at some of those systems, and there were a lot of leaks in the field. Just the engineering of the system, I'd say, was maybe that would be too brutal to say it was primitive, but there was a lot of water running everywhere except into that crop, and so I thought, wow, my gosh, this is not going to be very successful. Well, if we looked at then the yields, and I'd say this can be very, I'd say, looking at it, that it's been driven both for yields have been driven by genetics, variety improvement, but also this drip irrigation system. So if we looked at the yields, they've just gone up. This is the average across the years for California. And we can see yields back in the 1990s or so being 30 tons or so, and then just continue to increase. And so we can look at this timeline and look at it as when drip really became much more prominent. And we can see that yields have increased and along with this timeline when drip was being more widely used. And so if we looked at this this metric of how many acres of tomatoes are being planted, it's while there's ups and downs depending on the year, it's relatively stable. And I'd say that it has decreased because our yields have gone up. And that's what we're seeing here, that yields have just gone up. And it's almost a linear rise in yields from, I'd say, 20 tons back in the 60s and now approaching 50 tons. And it'll clear that 50-ton mark, although our genetics in the varieties, even the old varieties, it is 100 tons per acre. The genetics are there to clearly produce 100 tons per acre. And I was a young advisor when I went to, and I came from Davis, but we looked at experiment on the Fresno State University Research Facility, and an individual there showed us his plots. It was drip irrigated, subsurface drip. It was controlled by a little, I guess, a little sensor, and that he was irrigating every time that soil moisture dropped a little bit. This microsensor would click on the water. It was an old variety, a small vine variety, university-developed variety. It was UC82, very small vine, but concentrated fruit set. And we were able to see in those days when average yields were back in about 35 tons or so, maybe 30 tons, and this was a 100-ton yielding crop, 100 tons on an old variety. And so it really opened people's eyes, opened our eyes in terms of for myself to saying that there were strategies during the growing season when these very proficient, high-yielding growers were talking about water stressing during full bloom so that, or very much sort of a vegetative stage, to get these plants to become more fruitful. So showing the idea of sort of looking at weeds and saying when they became water stressed, that those weed plants would then want to set seed and become more fruitful. And with this drip irrigation experiment on Fresno State, it showed me at least that full-on watering, keep that that plant fully watered, matching ET made the most sense. Brought our yields up, and that's I think what's happened with our drip, better uniformly distributed water. And here, this is an experiment. I mean, there's a bunch of charts there, but basically what it said to me, this experiment for several years run by irrigation specialist Blaine Hansen and Don May, an advisor down in Fresno, that those two had worked with drip irrigation early on. And what it said was that in the early days, when yields were, let's say, 35 tons per acre, that water use did not change to make this a 50-ton crop. The same amount of water, the same ET rates were needed whether it was a lower yielding or higher yielding. It didn't make that difference. So we're getting increased water use efficiency out of this system with this drip tape. Okay, and here's Tim Hartz, who did a survey apparently of growers in California, and the red dots are looking at furrow irrigation, and the blue dots with drip irrigated systems. And what I'd say the bottom line for me is this, that when we look at these high yields on this axis, and water use in inches per ton of fruit, so that metric, what we can see, I'd say for myself, is that these high yields are very concentrated, but not, I mean, there's outliers too, or there's different examples, but the bulk of it is occurring right in here. So high yields, reduced water use, because in terms of that metric of tons produced per inch of water. And we can see that, in the case of the furrow systems, much more variable. And we see that, of course, with furrow irrigation systems, the traditional systems, that there's water that's leaving the field. It's that thing that Dan Putnam talked about, with flood irrigation, although in this case, tomatoes is not totally flooded, it's channeled in furrows, but there needs to be some wastewater there to get a uniform soil moisture, at least into the lower part of the field. So there's inefficiencies involved. In terms of nitrogen, people talked about, with the water, what's happening with the nitrogen. I'd say that thing that Will Horwath, his experiment showing that in terms of greenhouse gas emissions, the subsurface drip irrigation has reduced those emissions. If we look again at some Tim Hart's and others' information, you can see that in terms of that metric about the nitrogen balance, that in the case of tomatoes in these 20 fields or so, that most of them are the nitrogen balance is very good. That it's they're not overusing fertilizer, and a bunch of that nitrogen is taken away in the fruit itself. So probably a good story, can be improved, but a good story with the candy tomato industry and nitrogen use. So are there some other challenges there? Here, yes, there are some complications. Yes, and I'll talk a little bit about this. Others have presented information. If we looked at cost of the system, I think our numbers are a little different than Dan's, Putnam's, but there's less drip tape in a tomato field. And for this annual crop that, at least in our Central Valley, for the most part, that tomatoes are a driver for drip irrigation in our annual crops. That other crops follow the tomatoes in the rotation, you take advantage of the drip tape, but tomatoes are the driver. About $1,000 per acre, $300 or so are in the investment into this drip tape. It's changed land rental agreements. For us in the Sacramento Valley, growers are partly landowners, but the bulk of the land tends to be rented ground, non-owned, but rented ground. And therefore, the leases have to be extended in order to pay for those type of investments. So it's an agreement with the landowner in this case. And others have talked about increased energy costs with compared to a gravity system because it needs to be pressurized. And so these systems are pressurized to have the 10, 12 pounds down into that drip tape. And there's been interest in getting a system that requires lower pressure to save energy with the drip system. Whether that can be developed successfully and have good uniformity, I think remains the challenge. And then what it's also done is that for growers, for the most part, even in the Sacramento Valley, that these systems, growers would prefer them to be on groundwater, on a well where they're controlling the on-off switch. Okay, but the price of that well is considerable, and some of these ones are a $200,000 investment into developing a well and having a motor on top of that. In terms of labor, I'd say it's been more of when we survey growers, it's been more of a sort of an even trade. That it hasn't been so much of a labor savings on irrigation. But what it's done is it's changed how irrigation is done and how it's being managed so that there's a manager controlling the hours of runtime. That seems to be the most important thing. The rest of the labor is perhaps turning on manually valves. There's some automated valve systems. But in our Sacramento Valley, it's been tending to be more manually operated with some bit of automation involved there. But a lot of this labor is, just as Dan has talked about, it's fixing these leaks. And the leaks are primarily driven by rodents. So, having a tape, growers have gone to thicker tape at a greater expense, but rodents, it's not the answer. You can have some pretty thick tape there, and rodents will, as Dan talked about, recreationally indulge. So, weed competition, great reduction there. So with subsurface drip irrigation, great reduction in weed competition. Not eliminated it, but reduced it. In terms of then other changes, changing the annual cropping pattern I think for us in the Central Valley, I'll shed a tear over that, but we're seeing so much almonds and other orchard crops displacing a lot of the annual crops here. So what it's done is intensified the crop rotation, especially to tomatoes. The cost of investment, as well as available land left over for annual crops, has really intensified the number of tomatoes in a given period. So that presents other challenges for us as well. Talked about divergent bed widths. People are playing with that. Primarily, I'd say it's not so much tomato-driven as it is rotational driven. That there's other crops that would fit better on a different bed configuration. Melons is one example of that, and as Dan has talked about, in terms of for tomatoes, a single drip line would be sufficient for a 5-foot bed or an 80-inch wide bed. I don't know what the metric measurement of that would be, but I'm not turning to Dan for that answer. So a single drip tape would be sufficient, but these alternate rotational crops, then it needs to fit into the system. And so I think that was the last slide for me. The summary of it is for tomatoes, water use efficiency has clearly gone up. And we think that yields will continue to rise, both because of genetics and continued use of drip irrigation. I'd say that we've seen especially soil types that have not been, traditionally have not been high tomato producers, that the use of drip irrigation has controlled the moisture management much better and has brought up the yields in those fields. So it's been a win-win for us. Are there some losers? And sure, that is the case. There's it's a high investment, and so are all growers able to invest? Even those growers who might have been in the day have been 1,500-acre tomato growers, that when they were question asking why, if drip irrigation is so good in raising yields, why wouldn't you put all your farm, your entire farm into your entire tomato farm under subsurface drip? And you're saying, wow, the cost, we just can't manage that expense all at once. So, yeah. Okay, well, thanks.